Good morning. Next condensation reaction of aldehydes and ketone is knoevenagel condensation reaction. What is that? Knoevenagel condensation reaction. Knoevenagel condensation reaction. Okay, in knoevenagel condensation reaction, it is a condensation of an aldehyde or ketone with an active methylene compound in the presence of a base like amine to give alpha beta unsaturated compound. So what is that knoevenagel condensation? It is the condensation of aldehyde or ketone with an active methylene compound, in the presence of a base, like amine to give alpha beta unsaturated compound. So what is knoevenagel condensation? It is the condensation of aldehyde or ketone with active methylene compound. What do you mean by active methylene compound? In active methylene compound, a CH2 group is flanked by two electron withdrawing group. Okay, let us come to that example for active methylene compound. Before that, what is knoevenagel condensation reaction? It is the condensation of aldehyde or ketone with active methylene compound in the presence of a base like amine to give alpha beta unsaturated compound. So this is knoevenagel condensation. Now, what do you mean by active methylene compound? In active methylene compound, we can see that active methylene compound, we can see that CH2 group is flanked by two electron withdrawing groups. So what is that? A CH2 group is flanked by two electron withdrawing group. What is the meaning of CH2 group is flanked by two electron withdrawing group? Let us discuss with an example. Example is malonic acid. This is an active methylene compound, malonic acid. What is the structure of active malonic acid? CH2, COOH and COOH. This is malonic acid. What is the actual structure of malonic acid? That means CH2, COH means C double bond OH, and here also you can see that C double bond OH. We have discussed the CO group. The CO group is electron withdrawing group. This already we have discussed. Okay, here is also another CO group. These CO groups are electron withdrawing groups. Now you can see that a CH2 group is in between two electron withdrawing groups like CO. So such type compounds are known as active methylene compound. What is active methylene compound? A CH2 group is flanked by two electron withdrawing group. Now you can see that this CH2 group, the CH2 group is between two electron withdrawing group. Here also COH, here also COH. We know that the CO group is electron withdrawing group due to the partial positive charge on the carbonyl carbon that we have discussed already. We have discussed this type of compounds are known as active methylene compounds. One example is malonic acid. Another example is diethyl malonate. So example for active methylene compound, one is malonic acid. Second example is diethyl malonate. That means this is a estro-malonic acid. That or you can call it simply call it as a malonic ester. Diethyl malonate. These are the common example for active methylene compound. One is what is that malonic acid, and the second one is diethyl malonate or malonic ester. Now let us go through the reaction. That means knoevenagel condensation reaction. So it is the condensation of aldehyde or ketone with an active methylene compound. We can see that this condensation, this knoevenagel condensation is mainly given by, even though all aldehydes and ketones are giving knoevenagel condensation, but it is mainly given by aromatic aldehyde, or you can see that aldehyde which does not have alpha hydrogen will give knoevenagel condensation in a good manner. Okay, that means we can take benzaldehyde. What is benzaldehyde? It is CHO ring, CHO. Here you listen very carefully. I am writing CHO as CH double bond O. Correct? This is benzaldehyde. So keep it in mind, this knoevenagel condensation will be given by both aromatic aldehyde, aliphatic aldehyde and ketone. But we can see that aromatic aldehyde will undergo knoevenagel condensation at a faster rate than aliphatic aldehyde or ketone. That is why we have taken here benzaldehyde with active methylene compound. I am taking diethyl malonate. So what is malonic acid? CH2, C double bond OH. This is malonic acid. It's ester with ethanol. So here it will become C2H5, and here also C double bond O C2H5. This is diethyl malonate. This is an example for active methylene compound. Actually, malonic acid CH3COOH, and you can see that ethanol, acid and alcohol. Here also another molecule of ethanol. That means you get this ester, diethyl malonate, malonic acid and ethanol, diethyl malonate. Okay, this is an active methylene compound. Why it is active methylene compound? This CH2 group is surrounded by 2 electron withdrawing groups. Here also CO group, and here also CO group. That type of compounds are known as active methylene compounds. In the presence of a base, I am taking the base. Look at it here, NH, and this is a 5-membered ring. This base is known as pyrrolidine. Pyrrolidine. This is the base. This is a amine. This is amine NH. This is NH. Okay, this is amine NHO group. Okay, NH, and it is a 5-membered ring. That base is known as pyrrolidine. In the presence of a base, what is happening? Look at it here. I can write this CH2. Okay, when you write, you have to write another structure. So I am changing here only. This CH2 can be written as CH2. Okay, I am changing here only, and you can see that what will be eliminated. H2O will be eliminated. Okay, you write separate structure and show separately, and what we get a structure like this. Here it is ring. Here it is CH, and you can see that double bond C, and here it is C double bond O C2H5. Here also C double bond O C2H5. First we get this intermediate. This on hydrolysis, basic hydrolysis, H2O OH minus in presence of basic hydrolysis. And you can see that as we discussed earlier, what is that? C double bond O, it will change into OH, and that means water is coming, HOH. This will change into COH, and this will change into C2H5OH, ethanol. Similarly, here also you can see that OH, this part will change into C double bond OH, this will change into C2H5OH. So what we get? We get a structure like this. Here it is okay, CH double bond C, here it is C double bond O, this will change into OH, here also C double bond OH minus, or you can say what will be the second product? C2H5OH. Water molecule is hydrolysis only. This part will change into COH. This part also will change into C double bond OH. Then remaining OH, C2H5OH, C2H. That means plus what will form 2 molecules of C2H5OH. Okay, clear? Now you can see that anyway this is leave this ethanol. This part which upon heating will undergo you can see that what will be eliminated. You can see that this C double bond OH can be written as you can simply write COOH. COOH. You can see that upon heating, what will be eliminated? It will undergo decarbon. The CO2 group will be eliminated. Okay, C double bond OH can be simply written as COH. Okay, correct. Now you can see that upon heating, what will be eliminated? From one COH group, what will be eliminated? CO group. So minus CO2 group. CO2 is eliminated. What is remaining? You get a structure like this. Here it is a ring, and here it is CH double bond C in that carbon. CO2 is removed. One hydrogen is there, so it will change into CH C. And after removing removing CO2, what is hydrogen is there? That hydrogen is joining with the carbon CH, and in that carbon there is a COOH. Okay, we get cinnamic acid. Cinnamic acid. This condensation reaction is known as knoevenagel condensation reaction. Okay, so I am taking benzaldehyde. You can take any aldehyde or ketone. This is an active methylene compound. CHO group can be written like this: CH double bond O, H2 is eliminated, and what we get this compound CH, then double bond C, then you get this compound, which upon hydrolysis, adding water is adding here. So OH is joining with O, and OH is going with the C2H5. So you get this acid, and plus 2 molecules of C2H5OH. This molecule upon heating will undergo decarboxylation. CO2 group is removed, then CH COH, we get cinnamic acid. This condensation reaction is known as knoevenagel condensation reaction. Thank you.